Hey YouTube. So let's do some experiments. What I want to play with right now is I've got this crypto miner. This is an Antminer D3, and if you look these up, these aren't really profitable any longer. Basically, you're going to use more. You're going to spend more in energy than what you're going to get in return with crypto. But I want to play with this because I'm not worried about it, breaking. Right? I don't want to experiment with a profitable miner, because then if I break it, then that's losing profit, right? So what I want to do is I want to experiment with running it off batteries and ultimately running crypto mining with solar power. So, one of the biggest expenses in crypto mining is your power bill. So if we can, use free power from the sun to do our mining, then, we wipe out that big expense. And at some point we ROI, which is return on investment, with all your solar equipment, any kind of batteries that you have, your mining equipment. Then once you ROI, then it's all just straight profit from there, baby. So here's the thing. These things have these giant power supplies. This is a, if I ran this at 240 volt AC, it would be able to produce 133 amps. At 120 volt AC, it'll max out at 100 amps. But if we're running off battery, and it puts out 12 volts, right? So the idea is, let's eliminate this because this has some power, inefficiencies. It's probably, it doesn't really say, but I suspect that we're probably like 80, maybe 90% efficient at the most. So we're potentially losing 20% of our energy from this guy. The other thing is, if we were going to use this power supply to power the miner, we would also have to have an inverter, an AC inverter. So there's some power conversion loss in that as well. So you're talking about maybe another 80-90%. So in total, if you were to use a AC inverter to convert your DC power that's generated from the solar into AC, and then using this to convert it back to DC, you're potentially losing 40% of your power. So my idea is to connect this directly to a 12 volt DC battery, and then ultimately, if that works out, then we have a bunch of solar panels and charge controllers that would provide that 12 volt DC. That the charge controllers would buck down the solar panel voltage to 12 volt DC to supply power to a battery bank. Maybe not necessarily a huge battery bank, I don't know. I have to figure that out. And then power the miner. Not necessarily expecting that this would run 24 hours, but running during the daytime when there's plenty of sun, it's free power after you've ROI'd all your equipment. So anyways, let me show you what I've got. So here's a battery bank that I've built, and I'm not sure. I think these are probably 100 amp packs. I built them up from individual cells that I got from Jehu Garcia. And I've actually yet to test the capacity on these packs, but they're all spot welded together, and they've got some copper wire to help carry the current. I've got a shunt so I can see what the power draw is, and then these are all the wires that were originally connected to this guy. Luckily, I just I was able to unscrew them and screw them to these bus bars, and the screws fit and everything. So it was like kind of a perfect situation. So I got my positive and negative. The other thing to consider is your 4S. These are lithium iron phosphate. Your 4S lithium iron phosphate, when they're fully charged, they're going to be more than 12 volts. They're going to be 14 plus volts. That these things are going to have. So that exceeds the specifications of this guy. So I haven't. I tore down the little control board here, and I could see that. Hold on a second. Let me get my glasses. I could see that the components would handle over 12 volts. Yeah. For example, this board has a buck converter in it that powers a microcontroller. If I can pull it out here, we can see. And this is basically, I don't know if you've ever heard of a beagle bone, but this is a beagle bone, just flipped upside down. It's a microcontroller board that you can for hobbyists actually, that you can just buy. But this one's made by Antminer, so they use the open source CAD files to assemble this board. But that's made by the company that actually makes this miner. And anyway, so there's a buck converter underneath here, and I looked at all the components, and they were able to handle it. Like I'm looking at the capacitors here, and they're rated for 16 volts. So my battery bank's never going to get up to 16 volts unless something terrible happens. So that will handle it. Let's put that guy back in. And then looking at the components on these hash boards, there's little boards inside here that do all the arithmetic to do the hashing, hash the cryptocurrency. And the components, as far as I could see, they were rated well enough to to handle over the 12 volt rating. So I think this thing's going to be fine. So all there's left to do is for us to hook it up, and hopefully it doesn't blow up. If it does, again, it's not a profitable piece of equipment. It would it would be fine. It's not like we're going to damage an expensive piece of equipment. So I'm going to go ahead and hook this guy up. There we go. So yeah, there's like a ton of wires here. And then the last one goes to the little control board. So the hashing cards are all hooked up to the wires, and so is the control board. We're going to hook up the Ethernet cable, that way I can log into the interface and see if it's actually working. Actually, I think I want it to face this way because the heat's going to come out this way. And yes, it does generate quite a bit of heat. This thing probably, I suspect, anywhere from 800 to 1,000 watts. So it's going to produce definitely going to produce some heat. Okay. Let's see here. Oh. Okay. Oh, I need to hook up my backgo so I can monitor the cell voltages, because I don't actually have a large enough 12 volt 4S BMS. So I'm going to have to be the BMS, but I'm going to watch it the whole time. Make sure everything's tight. Yes, everything is tight. Okay, so when I hook this up, I don't think it's immediately going to draw a whole lot of power, because it has to go through its startup cycle, and then it starts up the hash boards, and then it starts drawing a lot of power. So I don't have a switch to put in here, so I'm going to have to just put it on this terminal here and tighten it down. And when I want to stop the test, I can go into the interface for this and tell it to shut down. So it'll basically go into a low power mode, and then I can remove this cable. So here we go. Oh, got a nice little spark. I hear the fans coming on. Not really drawing any current yet. Get that nice and tight. Usually takes it a minute to go through its process, so. Oh. Whew, that's loud. So that is, oh wow, I think it's going. You can see that. We're drawing 80 amps. At one sec, just a minute ago, it was drawing, or just a second ago, it actually went a little over a kilowatt. So right now we're drawing 982 watts. I'm gonna go look at the interface real quick. Yeah, so it's actually working. Yeah, we're drawing over right at about 1 kilowatt, 81.5 amps. And looking at the status over here in the mining pool, it's producing. It's doing 3,571 megahash on an X11 algorithm. It's like a heater. So right now this is all battery. This is a battery directly to the miner. Yeah, so I think these wires are a little undersized, like 6 gauge or something like that. They're getting warm, but they're not melting or anything, so that's good. The batteries are cool, very cool. Yeah, so I'm gonna let that run, and this is noisy, and I don't think you guys want to sit here and watch this. So I'm gonna let it run, and let it run these batteries down, and then I'll come back and we'll see where we're at. All right, guys, I am back, and I like the results. The specs on these miners say 11.6 volts to 13 volts. I actually let it go down to 11 volts and it was still running just fine. Now, if I were going to do this on a daily basis, I would probably have the BMS program to cut out at 11.6. That way we don't go below that spec. I'm more concerned with going to too low of a voltage, because when you start to go lower voltage, then your current starts to rise. Some of the components may be not able to handle that higher current. There's also like low dropout regulators and things that are in these that only function at a certain voltage level. Like it's supposed to be, like a volt up above of what it's trying to regulate down to. But anyways, yeah, like I said, it went down to 11 volts, and I went ahead and killed the test at that point. The batteries discharged to 110 amp hours, so that's actually great. I was actually wanting to do a capacity test on those batteries. They still had some left. I think it was sitting at around 2.8, between 2.8 and 2.9 per cell. So I pretty sure these would have went to 120 amp hours, which is about right. There's 40 cells at about some of the cells are 3 amp hour cells, and the other ones are 3.2 amp hour cells. So 40 cells. That pretty much equals around 120 amp hours. So I think these would have probably gotten pretty close to that if not hit it. But anyways, enough of that about that. So this is the Antminer crypto miner running directly off of a 12-volt lithium iron phosphate pack. It worked flawlessly. We can run the miner, the ASIC miner, directly off batteries. So the next logical step is to add in some solar charge controllers and some solar panels, and run the ASIC miner directly off solar. And the batteries, you don't have to have a whole lot of batteries, because the batteries are just really there to as a buffer to keep the system running. You need the batteries because the sun's, you're going to have a little cloud, and the cloud's going to open up, and then you're going to have full sun. So this is just there to keep the system running, so you can store some power in it, and you don't have the power just like constantly going up and down. So yeah, that was a cool test. That was definitely very interesting, and I like the results. And we're going to do another video where we're going to hook this up to solar. There we go. I hope you enjoyed the video, and I'll see you next time.